Thank you. Everyone here okay? All right. Show in the room. Hands up anyone who's heard of Neo4j before or used it. Keep your hands up if you've used it. That's cool. Looks like about a quarter to a third of the people who are here. Okay, so I'm going to spend the next 20 minutes going through some examples of observing customer journeys and how we can use the Neo4j platform to look at that and to actually do some data engineering and to manufacture some more information about what we know about our customers, and also touch on roast chicken along the way as well. So, analysing it. So I'm going to talk a little bit about graphs, and we'll look at what we can understand about our customers, looking at their interactions and how they interact with your business. I've got a couple of examples, one of retail and one in telco. What we can learn from these customers, and how we can arrive at mutually beneficial outcomes. I'll just head off the stage. I'll start though with a bit about graphs. So I joined Neo4j almost a year ago. I've got a history of working in databases in the past, and worked at IBM and worked in industry models. And when I first looked at graphs, they looked like to me a logical, very high-level, logical, conceptual view of a system. But what I rapidly learned was that they're actually a lot more than that. This is the actual data. It's what the data looks like. So a graph stores information. A native property graph like Neo4j stores information very, very differently. And it's stored using these constructs. Whoops, well, excuse me, where's the pointer gone? These constructs such as nodes. So I'm going to go through these now. So a node is the key plank of storage within a graph. It represents an entity. We have relationships which connect nodes together, is what we're seeing here with these arrows, invest and owns. We have properties which describe the node or relationship. These are like attributes. A label is a way of classifying a node. So we've got in this example here, we've got person nodes, we've got and a node with that represents a location and a residence. We can actually have multiple labels. And then finally, there's the relationship type itself. So in the example here, we've got married to, lives with, lives at, owns. These are all examples of relationships. Now, if you've done looked at any literature, literature on graphs, you'll hear about vertices and edges. Well, in this world, a node is a vertice and a relationship is an edge, and you'll see that, those terms come up frequently. So, a couple of things I want to point out. There's multiple relationships, so you'll see that Michelle and Andre, these two people, they're person nodes. They're married and they live together. You also see we've got some properties there. They've got their name, they've got their date of birth. One's got a Twitter handle and one's got a status. So we're schemaless. We're not imposing a rigid set of properties on every possible node. Okay, so they can absolutely be mutually exclusive properties there. So I'm going to move on to the next. What I want to stress is that physically this is what's being stored. All of these components here are first-class citizens, specifically the relationships. So when you're thinking about graphs, it's the relationships and the links and the persistence of those, and those becoming part of your data and letting you address the data, which I'm going to go into shortly, which are the key tenet for using graph technology. There's no graph-like view over a veneer over a document or a relational structure going on here. We actually are storing this information with pointers persisting it on disk, which will lead to something like this. Now, there's multiple domains here. If you look carefully, you'll see we've got a customer. And this is a meta model, so I'm only showing the labels. The actual model with real data would be a lot busier. We've got our customer. We've got employees who have interacted with customer, potentially via devices. And if you look carefully, you'll see lots of people having sessions, placing orders. There's lots and lots of different domains here. So very quickly, as your graph evolves, and it can evolve from a very simple state, and then evolve, and you can very extensible, very easily extended to look something like this. But it can look complex and start to get complex. So yes, it's starting to get complex. So how do we reach into that and address that and use it? Well, we have a dialogue called Cipher. There's actually a project called Cipher as well. It's our query language that we use to reach in and get data out of our graph. It's very much like, it's not like SQL. It's like SQL for graphs. It's not like SQL, but it is. It's a language for graphs, which is inspired by SQL. So we focus. It allows us to focus on what we want to pull out. So those relationships that you've seen there, we're going to go and address it. We're going to go and address the graph in that way. So if we look at this query down the bottom here, this one here, we've got the beginnings is a very basic one. We're saying a keyword is match. Match, you see something a lot in Neo4j. Match the label person with the person with the name Dan. His loves relationship. We actually don't know who this is. We can just say whom, and that's a variable that gets returned. We can interrogate that and see who it is, in fact, that Dan loves. So, just to look at some examples of Cipher in action, who owns the house at this particular street? So at this same picture we saw before, the query looks like this. We're addressing a couple of nodes. We're matching the person who owns the residence, where the address is 475 Broad Street, and we return P, and P is actually that person. Okay, so we would get Michelle back. Just to extend on that, who's married to the person who owns that house? The query gets a little bit more complex. Same query, just a little bit more information. We say, referencing the married to relationship to this other person with P2, and we return P2.name, and this is giving us this person, Andre, who's married to Michelle, who owns the house. Right, so there's some basic examples of Cipher in action. Why is customer journey analytics important? Well, if we understand our interactions with customers, interactions with our business and remember them, then we can have a personalised relationship with that customer, and they're going to value that relationship with your business. From a business point of view, if you have an overview of the customer's experience, then you can go and exploit those. Well, exploit's a bad word. You can go and use those channels, departments or things, channels, and derive value, which is beneficial for not only yourself but for your customer. So a broader customer journey analytics model would have multiple domains. Customer is central to the model. It's like, you may have heard of the term customer 360. This is an example of a customer 360 model. There's multiple domains. We've got their web activity, their tweets, any promotions that have been served to them, their friends, any households, any householding, so relationships about people living under the same roof, for instance, any support interactions that they've had. So it gets very rich. But what I'm going to do now, because we're at a data engineering conference, I'm going to spend a moment giving some examples of how we can do some data engineering functions on the data in a graph. I'm going to pair it back to quite a simple example, shopping example, and spend a few minutes on that. So we've got this individual, Albert. He's been shopping. He's made 3 trips to a supermarket to do some shopping. Okay. Three different purchases on 3 different occasions. On each occasion, he's bought roast chicken. So there's the roast chicken I was referring to earlier. And a couple of occasions, he's bought product. He's bought beer nuts as well. He shopped at McKinnon and he shopped at Bentley. For those who know the area, they're geographically quite close to each other. Now, looking at this data, we can see that every time he shopped, he's gone and bought roast chicken. So we can make an inference from that Albert really likes roast chicken. And he also likes beer nuts as well. So what you can do with Neo4j, not only query, but you can also go, as I was alluding to before, you can also go and manufacture other relationships and build out your graph to be more addressable and more useful. So what we've got is we've got a bit of code here. I'm not going to step through the whole thing, but it's a bit of what we call that Cipher code. And the key thing here is we do a bit of aggregation and decide, look at how often they're actually making a purchase, and then build a strength attribute, and then this merge command lets me create a new relationship. So I'm going to create a relationship between the customer and the product, and I'm going to set a strength whether something's strongly liked or is medium or they're indifferent. What happens in our model is we actually get a new set of relationships. These 2 likes now directly from Albert to these customers. Now, if you look at this, that's just a really simple example. If you go back to that really complex customer analytics example I had with multiple domains, use your imagination to think of the sort of things you could do to evolve that graph and go and build more and more relationships in there to make it become more addressable and more usable. I'm just going to step through a couple more examples. They also, you may want to attribute your customers. So some customers in retail have heard the term pantry stuffer. So where customers buy something more of something when it's on sale. So we can run some analysis to see if that's in fact the case, and we can set the shopper type to be a pantry stuffer, and then in the attributes for Albert, he's now been classified as a pantry stuffer, and we can use this. I'm going to come back to how we can use this in a moment. The final one is to set what's their favourite store or domicile store. When I worked in database marketing many years ago, this was a thing they used to refer to as a domicile store, the one that was central, the one they used the most. We're setting a new relationship type here. So the graph has now evolved. This really simple subgraph has now evolved to have these three other relationships here now, and we can use those to drive new questions and not even have to touch the other information. So reaching out to customers now. I'm just going to go back a moment. If you have a look here, there's also a flooding event at a particular store. McKinnon had a flooding event, and there's probably some customers who are impacted by that. So we could reach out and say, well, match those events and the store, and who had that favourite store, and the particular products that they like. So who was affected by the flooding event at McKinnon? Let's proactively reach out and with an offer for the products that they like. The marketing offers to customers. So using that pantry stuffer example I just spoke about, you can match products to the customers at a particular store, and you can make offers for them to go and visit that store. So there's any number of different applications of that. I hope I'm getting the message across. All the while, I'm using these new relationships that I've derived just by doing a little bit of engineering with the data. So back to our model, we wind up at once in the centre. I want you to consider when you've got a model with more domains and the types of things that you could do. Think about those examples I just gave, and then think about in your world of with multiple domains about customer. It doesn't have to be customer, it could be something else, could be product, could be some other type of 360 view. But use this as just I hope I've been able to inspire some thought there. Now I've got another example which is slightly different. It's for telco. This is a path. So graph databases, Neo4j particularly do this very well. Does it very well. Is we can build a relationship. It's actually a simpler relationship here. It's not someone bought a product. It's actually a chain of events. So there was a service subscription which was someone established with a business, and all of these little pink nodes are all effectively a monthly statement of usage. The larger, more obvious ones are ones where the customers had an adverse relationship. And you'll see, if you look carefully, we'll see there's been phone calls, there's been help desk contacts. Ultimately though, what happened was we have a non-renewal event at the end, 13 months later. And that's a consequence of, very likely to be a consequence of the experience that they've had, which included, in fact, a no service impact towards the back end of the, 2/3 of the way through their journey. Now, this sort of information can be used in data science. Our intuition of looking at data can get us so far. We also have data science capabilities within Neo4j to take us further. So if we were to, that churn prediction you just saw a moment ago, we could take that sequence of events and use that as an input into some models to then go and look at things like churn prediction and link prediction. So we actually have link prediction algorithms that can assist us with that. We've also got, there's multiple use cases. I've just highlighted a couple of other ones. I'll just say it, just read it. and segmentation. In an age now where we don't have, where cookies are getting harder to do, we're starting to use, you may be limited to using things like device IDs and locations and browser types and things like this to try and identify who someone might be. You may not ever actually know who the person is, but you can build a profile of that person when you see that person come along and do some collaborative filtering. And make them offers, give them personalised recommendations. I think if you look back to what we were doing earlier on in the graph and looking what people like, that's a step towards, that's one of the steps towards building out a recommendation engine, which is one of the key uses of graphs. And I would, if you're interested in disambiguation, I got it right, and recommendations and the like, I'd encourage you to have a look at a case study called Meredith Corporation in the US. Now we have over 65 algorithms. I've highlighted the link prediction one, which we could potentially use for looking for things like churn or non-renewal, for instance. Encourage you to look at these. We have online readily available online information and many topics on Medium which discuss the application of these. To get data in and out, getting back on the engineering trail, getting data in and out of Neo4j, we've got a number of different ways. We've got that Cipher language that you saw. I can read CSV files there. We have a stored procedure library called APOC. We've got some tools that you'll be familiar with. So for real time, things like Kafka. We've got some older traditional tools like Talend, some newer ones like Hop. We've got Apache Arrow. There's Apache Arrow's the Apache Arrow project has a sub-project called Flight, which is the fast data transfer mechanism. We're using that. We've also got a GraphQL library, so if you want to build a GraphQL-based application on top of Neo4j, you're able to. We support a whole lot of different drivers, Java, Python. The other day I was just using, I've missed Spark and Databricks. We use that as well. I was using it just the other day with Jupyter to load Neo4j. Thank you. 3 minutes up. Nearly there. There's also some community developed drivers. There's actually more than that available as well. So to get started with Neo4j and learn about it, there's a couple of links. I encourage you to have a look at it. If you're interested, come and talk to us afterwards. You can also visit the Graph Academy, neo4j.com, and we also have you can deploy Neo4j on premises or use our managed service AuraDB, and we do have a free version for AuraDB as well that you can use indefinitely, obviously within some constraints. So with that, I'm done. I think I've got a couple of minutes to go. If there's anyone's got questions.
Thanks for that. Looking at that event path that you built earlier, now, obviously you can hand stitch that yourself, and there was a brief slide about the various sort of methods that are available. Is it possible within the Cipher language to say, match on this attribute and then use this attribute to sort of discriminate time, build me a chained link?
Yes, it is, yeah.
Fantastic, because building that by hand would be a real pain in the ass, so good.
Yeah. That was actually based upon topic, yeah.
Hi, it was fantastic presentation. Thanks for that. Just one question. Since it has a lot of models, like it supports a lot of models and languages, does it have capability to suggest the most optimized method of modeling? Because based on the data sets, I think one of the most time-consuming part is to identify which would be based on the data set, which would be the most suitable modeling technique. So does it provide the optimized method?
We do have tools that help you with that. So you will start with a use case, and your model will be your model design will be driven by your usage. But we also do have the ability. We have like reports that we run over logs to look at the way the platform is being used, and can suggest things, and we can look at cardinalities and how often things are being accessed, and have other recommendations. Yeah.
Awesome. Thank you.
Just a quick question for me. How does it work with really large data sets?
Works really well with really large data sets. You're going to need a bit of memory. We've got customers who've got billions of nodes running on a single instance machine. So, yeah, we do big data.
Awesome. Thanks, Andrew, giving us insights into Neo4j.